Good afternoon. Good afternoon to all. Let us find the time now to focus on grade 8 mathematics. We have to now focus on the volume as well as the capacity. And of course, this is the lesson of Friday, which is as always brought to you by the STEM Digital School. And of course, presented by Africa Teen Geeks. My name is Hendrik Makaneta. And of course, we are going to carry on. Let's carry on with the volume as well as the surface area. And of course, we are going to use the volume of a cube, area of a base multiplied by the area of the base multiplied by the height. So that's what we need in this case. And of course, we are continuing with our lesson on volume, where we define the volume of a cube as the area of the base, which is multiplied by the height. So the area of the base in this case, that will be the side multiplied by the side, and then the height, of course, is also another side. So if you look at the cube, all sides are equal, therefore the length is equal to the breadth, which in turn is equal to the height as well. So they are equal, and you should be able to find ways and means to calculate using this particular formula. So the main thing that I want to emphasize in this lesson is that you multiply the area of the base, and that must be multiplied by the height. Example of a cube, as you know by now, this is a cube with the side, and of course, we are going to demonstrate that the volume of a cube with the length S, it's V equals S cubed. That's how we define the volume. But before we can even continue with the lesson on volume, we need to thoroughly define a volume. Before I can even go to the rectangular prism as well as the triangular prism, and of course I'm going to also talk about the cylinder today. But before we can talk about all of these concepts, what is the definition? How do we define a volume? Now, a volume can be defined as the amount of space that a 3D object occupies. That's what we mean when we talk about the volume. So the volume is the amount of space occupied by the 3D object. And we, in short, say that how much space a solid occupies, that means a volume. Why is it important to study a volume? Well, a volume can be used in real life situations. There are a wide range of examples that you can think of. If you look at logistic companies, for instance, from time to time, you know, the transport of goods and, you know, merchandise, which require space, not only in where they are going to be delivered, but also the type of vehicles that are used and so on to ensure that the goods arrive safely. I mean, some goods travel from as far as abroad, you know, via the sea. You know, it may be necessary to understand the volume but also capacity, you know, and of course the surface area as well. And, you know, these are quite important concepts that we need to understand because they are used on a daily basis in a wide range of settings, be it in companies, be it in the terrain of education, everywhere. Volume is something that we need to study and be able to calculate as well. You know, you might want to, for instance, you know, utilize one of your rooms to buy, you know, you want to fit in any furniture, for instance. You know, if you don't know how to calculate the volume, for instance, you may not be able to buy the correct goods at times. But not only for you, but also for a wide range of companies, like I said, the logistics in this case being one of the examples. Right, I hope that it makes sense, and I've defined now the volume of a cube. And, you know, we know that we just have to multiply the area of the base of the prism, and then you multiply that by the height. And this is not just the height, but the perpendicular height. So very important, the perpendicular height in this case, meaning that the height of your prism should be perpendicular to the base. It should be perpendicular to the base. In other words, 90 degrees should be formed. If you look at this cube, you can tell that you know, at the base there, 90 degrees is formed because this is a straight line, just a perpendicular, you know, cube there with a perpendicular height, right? And the next one that I'm focusing on now is the rectangular prism. In this case, we define the volume of a rectangular prism with the area multiplied by the base. In fact, the area of the base where you multiply that with the height. So basically that is what we mean when we talk about the volume of the rectangular prism. This is the area of the base multiplied by the height. And I can give you an example. If you look at this box, this is a box which consists of the length, the breadth, as well as the height. And in this box, of course, you can see that if you want to check the volume, the amount of space, if you want to calculate the amount of space that can be occupied by this box, what you need to do is to calculate the volume. So that volume will give you the actual amount of space that is required for this box. And of course, you multiply the length times the breadth times the height. And volume, therefore, will be in cubic meters if you're working with meters, or rather cubic centimeters. So depending on the usage of the units of measurement, but it will be in cubic form. So therefore, consider the volume different from the surface area, which is in square numbers. Okay, and of course we are done now with the volume of just the example of the volume, how to calculate the volume of a rectangular prism in this case. And that's the second point that I've begun to make now. The third one will be the triangular prism. Remember that yesterday I gave you an example of a triangular prism during which we had the chance to calculate the surface area. And today I just want us to go back to the triangular prism, but this time we are now going to calculate the volume, not the surface area. And in this case, what I'm giving you is just the volume of the triangular prism. And we're saying here that the volume of the triangular prism is given by the area of the base. So remember, in all volumes, the first thing that you need to do is to calculate the area of the base. So you multiply the area of the base with the height. And we all know that the base of a triangular prism is always a triangle. Therefore, the area of a triangle, you should know it by now. It's half a base multiplied by the perpendicular height. So if you look at this formula now, I've said to you that the volume of a triangular prism is the area of the base multiplied by the height. And the area in this case, we said it's half of the base multiplied by h1. So the first height is height 1, which is right, the volume of a triangular prism is equal to the area of the base multiplied by the height. And if you can look at the height, if you can look at this height, I've characterized it as height 1 as well as height 2. So you can see we have h1 and h2. So basically that is what we have in this formula. And what is this h1? So it means basically we are talking about two heights or two different heights here. The first height is the height of the triangle. And the second height is the height of a prism. So basically there are two of those heights. The first one is the height of a triangle, followed by the height of the actual prism in this case. And I'm going to definitely show you as we proceed. In certain cases, the bigger height, or rather the height of the prism is also defined as the length. So like the example that I'm going to show you, you'll see that this height is actually defined as the length. As you can see that the volume of this triangular prism is half the base times the height. So h, the small letter h there stands for the height of the triangle. Can you see that? But the L stands for the bigger height, the height of the actual prism. So in that case, it's defined as L. But when we do the example, I think in certain textbooks, you'll see as well, when you use some of the textbooks, you will be told that the volume of a triangular prism is equal to half a base times the small letter h height, the small letter h, and then also multiplied by the big letter of h. So you'll have a capital letter h and the small letter h, where the small letter stands for the actual height of the triangle, and the bigger h stands for the actual height of the prism itself. So basically that is what you need to know. That is what you need to know. Now, I'm defining now the volume of a cylinder. Remember that we have already defined the actual volume. What is the meaning of volume? We said that the volume is the amount of space that a 3D object occupies. And the cube is used as a unit of measurement for volume. So we measure the volume in cubic units. It may be cubic meters, cubic centimeters, or cubic millimeters. Right? And of course, the basic thing that you need to always understand, even if you don't know, or if it happens that you forget the formula to calculate the volume of a cylinder, what you need to remember at all times is that the volume of any 3D object is given by the formula where you multiply the area of the base times the height of the 3D object. So once you know that, then you can calculate the volume of any 3D shape. You will not struggle because you'll know that once you know the base, main thing here is to know and understand the base of your 3D object. And once you know the base, then you can calculate the area of the base. In the case of a cylinder, we know that the base is a second. In the case of a triangular prism, we know that the base is a triangle. In the case of a rectangular prism, we know that the base is a rectangle. In the case of a pentagonal prism, we know that the base is a pentagon. In the case of a hexagonal prism, we also know that the base will be a hexagon. In the case of a cube, we know that the base is a square. So there should not be any confusion. The basic thing here is to understand that when you calculate the volume of the 3D object, you must calculate firstly the area of the base, and thereafter you multiply that area with the height of the prism. I'm sure that if you have a big a building, such as Carlton Center, for instance, and you are required to calculate the volume of that particular building there, you should be able to check the actual length and the breadth, as well as the height of the building. So if you have all of those 3 digits, then you can calculate the volume. You can be able to calculate the volume. Just for instance, even a box. If you're given any box and you have to calculate the volume of the box in cubic centimeters, once you have the length, the breadth, and the height, you can calculate the volume without a problem, because you know that you will take the area of the base and multiply that with the height. So now in this case, the volume of a cylinder is the area of the base multiplied by the height. And we should know at this point that the area of the circle is pi r squared. And then we multiply this with the height of the cylinder. And then, of course, we can take it from there. We can calculate this with the cylinder there, and then we take it from there. Let's now go on to calculate. But before we get there, I just wanted to show you just the picture of a cylinder. So we call this a cylinder, which consists of the radius there together with the height. Some of the reservoirs that are found in this country where water is stored, you use the volume, the formula. This is the actual formula that you use, to calculate the volume. So volume as well as capacity, go hand in glove. You need to know these things. Volume is very important, and at some point we'll come also to the capacity. Let us start now with the very first activity. Let us start with the first activity where we need to calculate the volume of a cylinder. Now I've given you the diameter of the circle as well as the height of the cylinder itself. Can we now use this information to calculate the volume? let's calculate the volume of a cylinder. Let us calculate the volume. The volume of a cylinder, I've just shown you the formula now to say the volume of any cylinder is given by the formula pi r squared multiplied by h. So in this case, we know the value of pi. Remember that pi is the same as 22/7, which in turn is 3,14. That is a given value. It's a very important mathematical value there of pi. So you have pi r squared multiplied by h. So basically that is what we have. So, but in the case of the challenge that I've given you now, there is no radius. You need to find firstly the radius. I think that is the hint that I can give you. Firstly, find the radius, then which will be followed by the calculation. So once you have the radius, then you are not going to experience any problem. In this case, you need to just find or calculate the radius first, and then you can be able to apply this in the problem here. Calculate the volume. Calculate the volume of the cube. Calculate the volume. So we will come to the capacity. Like I said, we are now calculating the volume. Right. As we calculate, I'm particularly interested in this example of the cylinder because it goes hand in glove with the capacity. Remember, we said in the beginning that the volume and capacity are very important. And we are going to look at capacity, which is the volume of a 3D object, given in terms of liquid measure. So when I was talking about a reservoir where water is stored, so remember, water is liquid. The capacity of that reservoir is measured in terms of the volume. So the capacity simply means the volume of the 3D object. So volume and capacity are related, because you can easily convert between units of volume as well as units of capacity. But capacity will be measured in millimeters or liters or even kiloliters. So you can express capacity in terms of cubic centimeters or in cubic meters as well. All right. So the conversion is going to come. At some point, we are going to show you that if you want to convert 1 liter, in terms of the capacity, we'll look at that, where you are able to convert a liter into a cubic meter, for instance, or cubic millimeters. Right. We are going to now demonstrate in this example that what is important. I see, let me check in the chat group. There's not much there. There's not much in the chat group, but let me demonstrate to you that what's important here, firstly, you need to find the radius. Whenever you are given the diameter, you need to use that to find the radius. And the radius in this case will be half of 10,6. Remember that 10,6 is your actual diameter. And of course, the radius will be half of that. So half of the diameter gives you the radius. If you move from the center of the circle to the circumference, that is where the radius comes in. It means you have the radius. So the radius will be half of 10,6, which is 5,3 centimeters. And the volume in this case will be pi r squared multiplied by the height. And we know that the value of pi is 3,14. And then you square the radius, which is 5,3. And then you multiply this by 28,7. Therefore, your volume will be equal to 2,532,7 cubic centimeters. So that will be the volume of the cylinder, which we are talking about. So the volume of this cylinder will be 2,532,7. All right. Okay, let's say this saying there, I do not understand the pi. Great. Let's say if I may call, or if I may recall, just to give you the pi there in mathematics. It's not the pi with an E, just pi, P-I. That's pi, like private investigator. Pi has got a value, and it's often defined as 22,7 or 3,14. So it's a mathematical value that is given. Throughout the life of mathematics or throughout your study of mathematics, you'll realize that pi is a constant. It's a constant value. It doesn't change. It stays the same. Right from grade 8 up until grade 12, you will see that the value of pi remains the same. Even at university level, if you come across any mathematical problem that you have to solve where pi is involved, the value of pi is constant throughout. The value of pi is constant throughout. All right, so the formula in this case is given by pi r squared multiplied by the height. So you simply multiply the pi there with the height. And I see, let's say this asking, what is the use for pi? What is the use of pi? Where do we use pi? Is there anyone who wants to answer that? The use of pi, what is the use of pi there? Pi in mathematics, all right. So pi can only be used in mathematics, all right. Okay, look, when we look at the area of let's talk about the area of a square. It's very easy to find the area of the square because you have the length and then you can multiply the length by the length. Even the area of a rectangle is the same. You can find the length and the breadth which are given there. And then even the area of, for instance, a triangle. I'm giving you these things so that you understand when we come to the cylinder, because a cylinder consists of a circle. All right. Now, we use a pi, when we want to calculate the area of a circle. And in this case, you multiply the pi by the radius, which is squared, as I've shown you in the example. Usually a circle consists of the circumference. The circumference is just that part where the circle moves. And then You also have the diameter, which is a line that moves in the circle. Cuts the circle into two equal parts, and you also have the radius clearly defined. Now, if you divide your circumference with the diameter of a circle, you actually get pi, which is 3,1415. It's quite a big number, the decimal number, but just to round it off, 3,14 is sufficient. So we use pi to find the area as well as the circumference of a circle. That is where we use it. That is why you will only find pi where the circle is involved. Like in the case of a cylinder, there is always a circle there. That's where you will be able to find pi. But when it comes to other 3D objects, such as the cube or the rectangular prism or the triangular prism and so on, you will never find pi there. We only use pi in the case of a circle, where the circumference of the circle is involved together with the radius. That's where pi comes in. All right, I hope that it answers your question. And I'm going to demonstrate with a class activity. Remember, we just calculated now the volume of the cylinder. And the first question that I want you to do now, or our class activity now, I just want us to find the volume in this particular instance. You are given now the cuboid, which consists of the length, the breadth, and the height. Can we now find this particular volume? Let's find the volume. Let us find the volume in this case. Right, let me give you a hint. If you look at these different values, the length is 0.5 meters. So the breadth is 40 centimeters and the height is 21 centimeters. So please convert your meters. Can you convert 0.5 meters to centimeters? Natalie, you are very quiet today. Musa, I see as well. Can we now convert our meters to centimeters? I think that's the first thing, so that you can work with the same units of measurement. That is what we're trying to do. Work with the same units of measurement. Let us work with the same units of measurement. Right, the 0.5 meters, we need to convert that to centimeters. So basically, we should know by now that 1 meter is equal to 100 centimeters. So that is something that we know. We know that 1 meter is equal to 100 centimeters. So this is something that we know. We know that 1 meter will be equal to 100 centimeters. This is what we know. So now that we know that 1 meter is equal to 100, so therefore 0.5 meter will be equal to, then it means that's half of 100 centimeters, then it means it will be equal to 50 centimeters. I'm sure you agree with me. I've just put that on the group chat to demonstrate the importance. So I see here Lynn has now calculated our volume there. So yes, Lynn, I fully agree with you there. Now that we have converted the meters to centimeters, so you can simply use the formula to calculate the actual volume. Can you give us the final answer there, Lynn? What is the answer that you got? 42,000 square, okay, cubic centimeters. You forgot to put 3. 2,000 cubic centimeters. So thank you very much, Lynn. The volume to calculate to calculate the volume of a cuboid, you simply multiply the area of the base by the height. And in this case, the height is given. We know that the height is 0. In fact, the height is 21 centimeters, and the length is 0.5 meters. So if you multiply that together, you get 42,000 cubic centimeters. Remember, the first thing first, you convert. So before you can even go forth, you just simply have to convert your meters. Now, without any doubt, I'm just going to proceed just to the next one. Very easy one. Once again, if you are given a cuboid with the length, which is 1.5 meters, as well as the height and the breadth, calculate the volume. Let's calculate the volume. This one should be straightforward because there is no need to convert anything. You are given the length, the breadth, and the height. So all that you need to do is just to substitute. And by the way, the formula for the volume is very clear. Length multiplied by the breadth multiplied by the height. Then you just substitute. So if I were you, let me tell you the first things that you need to do when you come across problems of this nature. I see Lynn has already calculated. The most important thing that you need to remember is just to demonstrate that your volume is given by the length multiplied by the breadth multiplied by the height. So that's the starting point. Once you have the formula, then you need to ask yourself a question: what is the length? And then the length is given. What is the length? The length is given by 1.5 meter there. So the length is equal to 1.5 meters. So you write the length there. So the length is 1.5, and the breadth, then you know that the breadth is 1.4 meters. And then you come to the height, and then you know that the height is equal to 0.7 meters. So you need to have the capacity to, or develop the capacity rather, to demonstrate that you can actually denote the different items. Once you have them on board, then you can be able to substitute. All right. You can just substitute. I see, Lynn, you have converted your to centimeters, right? I see people have converted, even Lesedi. Lesedi has now converted this to centimeters, right? Maybe let me clarify something. You don't always have to convert you don't have to convert everything to centimeters unless one of the units are in a different. The reason why we converted in this one here, in this first one, the reason why I said we must convert meters to centimeters is because the breadth is given as centimeters and the height is centimeters. We could actually convert, there's nothing stopping us from converting everything to meters, by the way. It is not compulsory to convert to centimeters. It's not. It was convenient for us in this case because there is only one length, which is in meters. So we had to change only one thing, which is 0.5 meters. Otherwise, there is no need to convert if you are not given different units of measurement. Like in this case, really there's no need to convert from meters to centimeters. You don't have to, because everything is in the same unit of measurement. So we want uniformity in relation to the units of measurement. So there is no need to convert anything in this case, because we have the same. Be that as it may, let me also appreciate the fact that you have the correct answers. I see you have converted. It's not a problem if you have chosen to convert, but you don't have to, unless there's one unit which is inconsistent with other units. Like the example that I've shown you in the past year, 0.5 meter is not consistent with other units of measurement, being the centimeters. So hence we had to change the 0.5 meters. All right, so I hope it makes sense. Right, and this case, you simply multiply. Remember that the most basic thing that you need to do is to substitute correctly. So in this case, you simply take the length. I've given you the length, which is 1.5 meters. So you multiply 1.5, and the breadth is 1.4. Then, of course, 0.7, that is the height. So basically, this is what all you need. You simply need to multiply the given information, 1.5 times 1.4 times 0.7. All right. 1.5 times 1.4 times 0.7. So basically, that is all that you need to do. Okay, so let's carry on now just to finalize the last one there. And of course, in this case, yesterday we had to calculate the surface area, but today I want us to calculate the volume using the same 3D objects. So using the same prisms, let's zoom directly into the first one. Remember, when we started this lesson, I gave you the formula to calculate the volume of the triangular prism. And I've equally said, you don't have to memorize the formula. Kids who memorize these things, if you forget one thing, then it means you stand a chance to lose marks, because if you lose one of the items there, then you may lose marks for a simple reason. If you do not find these things correctly, you may actually lose the marks. And of course, in the triangular prism, you do the same. You do the same. The most important thing is to know that you just have to multiply the area of the base, and then you multiply that with the height. So let's take the triangular prism, for instance, as an example here. V, which stands for the volume, is equal to, remember I said to you, the volume of a triangular prism is half a base multiplied by the height, which is a small letter h, multiplied by the bigger letter h, where the small letter h stands for the height of the triangle. So in this case, the height of the triangle, as you can see in the picture, it's 1 meter there. And of course, the base of the triangle is 1.7 meter. And the bigger height, now we're talking about the height of the prism, that is 3.2 meters. So basically, Before you can even solve your problem, identify all the tools that you need in order to solve the problem. So this will be half of those, and then you multiply them right into the equation, and then it should give you the final answer there. Once again, this lesson, as always, is brought to you by the STEM Lockdown Digital School in partnership with the Sasol Foundation. Until we meet again, thank you very much indeed.